Hello everyone, welcome to Con 216. Today we're going to talk about AWS Fargate and our serverless containers right for you. I am Saloni Sompal, a product manager on the AWS Container Services team, and with me I have one of our customers, Roy Penn, the VP of Engineering at Amenity Analytics, who's going to share his story about running their workload on Fargate. In this session, we're going to talk about briefly over the introduction of containers on AWS and AWS Fargate, some of the benefits that Fargate brings, the capabilities that it comes with, and given that it offers these benefits and capabilities, what workloads are a great fit for running on Fargate. And toward the end, we will talk about what we launched recently and what's coming up next on our roadmap. Containers have made it easy to build and scale cloud-native applications, but as usage grew, customers needed a way to manage the large cluster of instances, place their containers, and run services. ECS is a fully managed service which allows you to orchestrate your container services, and you can take advantage of the simplicity of cohesive AWS services in Amazon ECS. EKS is a fully managed Kubernetes service. EKS runs upstream Kubernetes and is fully certified Kubernetes conformant, which means that you can easily migrate any of your Kubernetes applications to EKS without refactoring your code, and you can use the same open source APIs and tooling that you are used to and leverage the vibrant ecosystem and community. The other part that customers need to worry about is where these containers run. On AWS, we offer two options, Amazon EC2 and AWS Fargate. Based on the benefits and considerations that we go over in this session, we will give you enough information for you to decide what's the best choice for you and your workload, whether it's Fargate or EC2. Scheduling and orchestration are a key component of ECS. Just to say, well, for simplicity's sake, we're going to use ECS throughout this session. That does not mean this content does not apply to ECS. It just means that the same concepts apply to ECS as well. Scheduling and orchestration are key components of ECS, and the cluster manager and placement engine play an important role in helping us accomplish these. The cluster manager essentially takes care of manages the health of the instances within your cluster. You set up an auto-scaling group and then register these instances with ECS. Here on, ECS knows about the instances that you want to use and the capacity you desire for your containers. The placement engine, on the other hand, enables you with much advanced techniques on how you want to place these containers on the instances. For example, you might want to place these containers on a specific instance type, or you might want to be super efficient with the bin packing of these containers for better economics. And the placement engine enables you to do both of that. But you still end up managing more than just containers. And you need to provision these instances, scale your workloads, patch these instances, and the software and the agents that are running on it, leading up to a significant amount of overhead. To take away some of this operational pain, we introduce AWS Fargate, which is a serverless compute engine that works for both Amazon ECS and EKS, regardless of what you're using. Fargate makes it easy for you to focus on your application and not so much on your infrastructure. In the past few years, we've seen a great adoption of production use cases on Amazon ECS and Amazon EKS. In fact, we are witnessing this crazy and incredible transition to containers and customers scaling their workloads on Fargate, be it Expedia, which is running the travel platform on Fargate, or Turner Broadcasting Systems, which is running some of their most popular websites like Cartoon Network or CNN on Fargate. ECS and EKS both allow you to run containers at scale on Fargate. And yes, indeed, we are running hundreds of millions of tasks and pods which have containers, every week on Fargate. So let's touch upon some of the key benefits that Fargate brings. Fargate is a technology that provides on-demand, right-sized compute capacity for your containers. You only pay for the vCPU and the memory resources that your containers need. With AWS Fargate, you no longer have to provision, configure, scale, or even manage. It's a very simple operational model. This removes the need for you to pick a particular server type or choose when to scale your workloads or optimize the bin packing or even patch your instances. We take care of that for you, which essentially means you get to focus on your applications and not worry about the infrastructure at all. So let's dive in details into each of these benefits. Let's double click on the serverless aspect of it. Just like ECS, you're running an instantiation of your task definition. All you do is you pick a different launch type, which is the Fargate launch type, and then you're able to run as many containers within a task. And with services, you can also maintain and run copies of your tasks. If the tasks get unhealthy, they automatically replace as a part of the service. Similarly, for Kubernetes, and EKS, you're essentially running pod, which is instantiation of your pod spec. And thing to note is that you don't have to change anything about your Kubernetes application. You just need a Fargate profile. If your pods in the Kubernetes application matches the namespace in your Fargate profile, those pods will start running on Fargate. And voila, you just have migrated from EC2 to Fargate, or you can use both mixed mode. With Kubernetes, you don't have services that take care of the automatic replacement, but you have replica sets. So there's similar concepts on both sides. The key thing is that Fargate does the operational heavy lifting for you. So you focus on your app and not the infra. All the patching is done for you. The automatic scaling is taken care of. You only have to scale your containers and not your instances and worry about those. One of the examples of customers, Vodafone UK Limited, is a very good example to drive this point home. They started their journey with AWS on ECS with Fargate, and as their scale grew, they started experiencing certain challenges related to scale, and their digital architects looked into Fargate to mitigate some of these growing pains and improve the platform stability. They're now halfway through their migration, and one of their key services, which is the My Vodafone app, runs on Fargate. They also, any new services or that they start under the digital services and channels are deployed by default on Fargate. This quote from their head of digital architecture phrases this really well and articulates the benefit really well. So I'm going to just read it out. By removing the complexity of infrastructure management and shifting some responsibilities like OS hardening and patching onto Fargate, we can reduce the amount of resources we spend on these tasks and instead focus on adding value to our Vodafone customers. That's exactly what we want all of our customers to experience, the hands-on experience. At Fargate, one of our core tenets is security by default. Each task or pod runs in its own isolation boundary, which is a VM or micro VM isolation boundary, and does not share any underlying kernel, CPU resources, memory resources, or ENI with any other task or pod. The security model is more of a shared responsibility model. We tend to do more and you do less, but it's still a shared responsibility. It's one task per virtual machine. So the virtual machines do not share any resources, whether they're CPU cores or memory pages. It's restricted VM access. We do not allow privileged containers, privilege escalation. We also only allow the default Linux capabilities, and recently have added the capsys ptrace to be added or dropped. But other than that, there is no runtime SSH access. So it is pretty secured, and these VMs are immutable. We also have network level isolation, which is one ENI per task or pod. These ENIs are used for downloading images. They're used for log streaming. They are used to download your secrets. Each of these essentially are done via the one ENI that is exposed for a task or a pod. It requires AWS VPC network mode, and this gives you one ENI and one security group for your task or pod. You can also use VPC flow logs to actually monitor your network activity. Each task gets its own dedicated storage. This is ephemeral in nature, so it lasts for the lifetime of your task. It is a 20 gigabit storage volume, and it is encrypted by default using the service managed keys. We also have one set of credentials, which is IAM set of credentials for each task or pod. That means that these credentials are visible only to the containers within the task or pod and none other. You can also bootstrap with encrypted secrets, and you can use CloudTrail to monitor the usage of these credentials or secrets. And last but not the least, it's the hands-off patching experience. We take care of the patching of the OS, the Docker agent, the Fargate agent, etc. for you, so you don't have to worry about it. And this is not just limited to software updates, but it's also extended to the security patches that come around when there is a CVE. This is truly the serverless experience. A Fargate task or pod with its own VM or micro VM isolation boundary looks like this. As you can see, it's a VM with each of the things that I mentioned on the previous slide, whether it's secrets, the agents, the ENI, the volume, they're all restricted, and there is no sharing of vCPU and memory and the kernel. Each one gets its own VM or micro VM boundary, and this helps maintain the strong trust boundaries by default, and also reduces the attack surface, whether in an event if a container escape were to happen and other such vulnerabilities were discovered. Another one of the benefits of Fargate and one of the key benefits that customers consider are cost savings. With AWS Fargate, there are no upfront payments. You only pay for the vCPU and the memory resources that you use. You can also take advantage of the compute savings plan, which is a flexible pricing model that can be used for your steady state workload, and you get to avail discounts in exchange for a commitment for a 1 or 3 year term. You also can avail up to 70% deep discounts with Fargate Spot if your workload can be interrupt tolerant, or are these applications interrupt tolerant. Fargate launches and scales the compute to closely match your resource requirements. So with Fargate, there is no over provisioning as such, or you're not having idle servers sitting around, or there are additional servers that are not being used at the time the application is running. You only pay for the vCPU and memory resources consumed by your containerized applications, which is where the cost benefit comes along. Also, tasks and pods are right size. So there's no more like my cluster is only 30% utilized or 50% utilized or what have you percent underutilized. The billing is at a per second granularity and with a 1 minute minimum that also lets you be very concise and save some on your builds. These are configurations that are available to run your tasks and pods today, and we are constantly expanding. The smallest one is the 0.25 vCPU and 412 megabytes memory combination, and the largest one, a task or pod that you can run, is on 4 vCPUs and up to 30 gigabit memory. We offer certain pricing models and pricing options. Compute savings plan is one of them, which spans across compute services in AWS, whether it's EC2, EMR, ECS, EKS, Lambda. And what happens is it's a flexible pricing model that provides you savings up to 72% across these compute options in AWS. And to avail these discounts, you need to make a commitment ahead of time in terms of dollars per hour of what you would use. This commitment is for a 1 or 3 year term. Once customers exceed this agreed compute usage, what happens is the billing reverts to the normal on-demand pricing. So you don't have to do anything, it's just automatic. And these discounts are applied whether you move from one compute option to another. So say today if you were using EC2 and the savings plan were getting applied to your instance usage, if you move to Fargate, that same compute savings plan can be taken over. You don't have to do anything. The discount just starts getting applied automatically. Particularly for Fargate, the savings plan discounts look like this. For the 3-year term, the discount for a no upfront option is about 40 to 45%, and up to 47 to 52% for all upfront payment option. For exact discount rates, please visit this URL at the bottom of the slide. Another pricing option is Fargate Spot. If your application is fault tolerant, you can use Fargate Spot to avail a deep discount of 70% compared to your on-demand pricing. This is a great value prop, and Roy will tell us later on in the session how they leverage this option and have achieved cost savings. Fargate Spot is today supported on Amazon ECS, the tasks that run on Fargate, but we hope to bring this to EKS pretty soon. As you can imagine, in this serverless world where there are no instances you manage and there are no instances you can SSH into, how critical logging and metrics are. So this particularly touches upon how we enable logging and monitoring for your Fargate tasks and pods. Last reInvent, we announced FireLens support. FireLens is a container log router that actually gives you the extensibility to use a breadth of services within AWS Cloud or the ones that are available via our partners for log analytics and storage. FireLens works with FluentBit and FluentD. So if you, this means that you can bring many plugins, including AWS FireLens or your own custom plugin, which uses FluentD output option. The AWS, for FluentBit, the image is managed by AWS, and you will see that it's available in all regions in ECR. How this works under the hood is the component that reads from your application container. It sits in the data plane, and then this application container logs, essentially the standard out, is then sent to the FluentBit sidecar. And this sidecar is then the one that routes the logs to the destination of your choice. FireLens gives you a very simplified interface to filter these logs. So what would happen is you would have certain filters or attach certain metadata and then route it accordingly to the destination of your choice, whether it's AWS services like CloudWatch, S3, Elasticsearch, or Kinesis data streams, and then process it later. Or there are partner cloud solutions such as Datadog, Splunk, New Relic that you can leverage. This has been out there for a year. ECS customers have been using it and have provided feedback. We definitely have been listening. One popular feedback has been, we need this for ECAS on Fargate. So I'm very happy to share that this reInvent, we are going to be adding support for logging for ECAS on Fargate. What this means is that it just does not bring the logging support, but we've also heard customers talk about, we don't even need to manage and maintain the sidecar, the FluentBit sidecar that I showed in the previous slide. So in this case, what we've done is we've taken that feedback and put it taken the responsibility on our data plane to actually manage this sidecar and the log router that just forwards these logs to the destination of your choice. Like we like to call it, it's now the hidecar. We basically use the same Kubernetes concepts of config map, which you can use on EKS and EC2 or Fargate, or self-managed Kubernetes options. As you can see, the partner cloud box is grayed out. At launch, we will not have this support, but rest assured, this is coming soon. We're already working with our partners. Another critical piece is monitoring. We want to make sure that not just logs, but metrics are available, so you can alert on these metrics and be able to view these in an aggregated or summary fashion in Container Insights. CloudWatch Container Insights supports ECS on Fargate today, and we hope to bring ECAS soon. What it does is essentially automatically collects the metrics for resources like CPU, memory, disk, and we've recently added network metrics for Fargate. This is how the dashboard experience looks like. You can see the trends for your resource utilization as well as your task utilization. Like I said, this works with ECS at the moment, but if you are using ECAS, the CloudWatch agent can be used to scrape the Prometheus metrics from your ECAS Fargate pods. We have a rich ecosystem, like you can see, of partners, which allow us to extend Fargate capabilities. So we're not just restricted to what comes with the service and the features. I spoke about earlier about Datadog, Splunk, and New Relic extending the logging and monitoring capabilities. And we have a rich ecosystem of partners that also extends some of these foundation, monitoring and logging, DevOps and CI/CD, as well as security and networking capabilities that your container workloads need. Talking about workloads, let's look at some of the actual workloads that are running on Fargate, so you can see which workloads are a good fit to run with ECS or ECAS on Fargate. One of the largest mutual funds provider and second largest provider of exchange traded funds, which is Vanguard, is running their web services and APIs on Fargate. You can imagine how security sensitive their workloads are, and the secure by default tenet just resonated with them so well as the taking away of the operational overhead. This is a quote from their chief enterprise architect, and Vanguard shoots to go all in on Fargate. Another one of our customers, Ancestry, is running at massive scale on Fargate and EC2. For just putting some numbers to this scale, Ancestry members have created hundreds of millions of family trees. There are about more than 13 billion ancestral profiles, which have been uploaded and attached, and more than 330 million photographs, scanned documents, and written stories have been attached to the trees. Another popular use case that we see on Fargate is data processing and some of the inference machine learning needs. Amenity Analytics is one of our customers that runs data processing, NLP essentially, and ML inference workloads on Fargate. They use Fargate to analyze large volumes of financial data, such as SEC filings, some of the meeting minutes, etc., and make inference about for their customers about predictive financial performance outcomes. Instead of getting a code from them, what I thought would be a great idea was to have Roy come and speak to us about their story. So I'm very happy to have Roy Penn, the VP of Engineering, Amenity Analytics, to join me and talk about their workload, how their workload benefits from the serverless approach and the pricing options that Fargate offers today.
Thank you, Saloni. It's great to be here to talk about why Fargate's serverless container solution was such a great fit for us. When we first set out to examine the benefits of Fargate a little over a year ago, we've already had a working architecture based on EC2 spot clusters. And it gave us the opportunity to design a simplified architecture that was all serverless based. As you can see here, documents that flow into our system go through a progression of serverless services, where the smaller, less complex parts of the work are handled by Lambda functions, and the natural language processing heavy lifting is handled by Fargate clusters. The way this architecture runs in real time, it has several dozens of such Fargate clusters running simultaneously. And each of them can scale out from 0 tasks to thousands of tasks in a matter of minutes. These clusters combine a base layer of on-demand tasks as well as a scale-out layer of spot tasks. This allows us to run both predictable, real-time, slow-changing workloads alongside unpredictable, quickly changing ones. In a normal case, there are about 1,000 new documents flowing into the system every minute, and Fargate sets its size to just several tasks. But when a new NLP model is created, a workload of tens to hundreds of millions of documents is created within minutes, and the appropriate Fargate cluster reacts and scales out automatically, processing the entire queue in just 1 to 2 hours. And now, more than a year in, after the first foray into Fargate, we're seeing some of the great benefits. First and foremost, our operational load was reduced. And relying on Fargate's out-of-the-box features, we could improve our ops excellence. It's easier on us to spin up massive clusters, to check their health, to be notified of errors, and to improve our overall quality of service. We've actually reduced our costs of operation while increasing the amount of data analysis we do. And lastly, we can now spend more time on our core competencies, innovating within our product to create more value for our customers. Here you can see a few examples of the actual business impact we're seeing at Amenity. In the past year, we've moved well over 90% of our workloads to serverless Fargate architecture. And what you're seeing here are two main benefits we've gained. The first is the time it takes us to process our documents. You can see that it takes between 5 to 7x faster on our Fargate Spot architecture versus our EC2 Spot-based architecture. So our customers receive our product in a timely fashion more reliably. The second is that it's about 75% cheaper per analyzed data unit for us to work with Fargate Spot clusters versus our previous architecture. So for us, it's clear that that using Fargate is an absolute win-win. Back to you, Saloni.
Thank you, Roy, for sharing your story. With that, we're going into what new features that we launched recently, which have helped grow Amenity Analytics and other customers, and what's next on our roadmap. One of the things that we invested in this year is the storage aspects. Many applications needed the persistent storage. They wanted to run stateful workloads on Fargate, as well as share data sets. So we brought about support for persistent task storage with Amazon EFS. We also increased the ephemeral storage size to 20 gigabits. We encrypt the ephemeral storage by default now using service managed keys. Another area that we focused on this year was to add more visibility, which is where we added network performance metrics via container insights, like I touched upon earlier. We also added the Capsys ptrace Linux capabilities, so you can use that for runtime security monitoring. We also brought about some usage metrics so that you can measure your usage against the approaching limits for tasks or pods in your account. Some of the other things that were launched this year were from ECS side, but automatically benefited Fargate is the dual stack support for IPv4 and IPv6. We also added developer tools such as AWS Copilot, which essentially makes it easy to start your applications on Fargate. One of the big announcements that's coming this re:Invent is AWS Batch can now run on Fargate. There are a few sessions where you can get a deeper dive into that. For ECAS specifically, since we launched ECAS at re:Invent last year, we've made sure to add some of the core capabilities to ECAS Fargate and also made it available where customers need it. So I spoke about logging, and we've also added NLP support and compute savings plan. 50% of the new AWS Container Services customers start on Fargate. These are pretty happy with the opinionated defaults that we offer. But one of the trade-offs that this comes with is that you lose some of the controls that come with if you are managing your servers or instances in the cloud. And we are aware of that. This is an opinionated stance that we have taken. So you don't get to bring custom armies. You don't get to do the customized bin packing that you would do with ECS on EC2 or ECAS on EC2. You essentially cannot pick the specific instance type. You just pick vCPU and memory. Some other constraints for the security aspect are that we do not allow privileged access or escalation. We also restrict the Linux capabilities that you can add or drop. Some of the other workloads that we want to enable on Fargate are Windows, ARM architecture, GPUs, and we are looking ahead, we want to enable these workloads with Fargate. This is one of some of the things that are on our roadmap, and we essentially want to delight our customers whether they're using ECS, EKS, or even Batch now. We will continue to grow our engagements with our partners as well as with the underlying platform using Firecracker, Containerd, or Fluentbit. We're able to engage with the community at the larger scale. That brings us to the end of our presentation. Thank you so much for joining. Roy and I are very excited to see how you go about and start running your containerized applications on Fargate. And if you had any questions about the benefits we went over or the workloads that you wish to run on Fargate, please feel free to reach out to us. Our emails are on this slide. And last but not the least, please do complete the survey. We would love to hear your feedback and anything that you had to say for this session. Thank you very much.